Hello everyone, welcome back to Electrochemistry Hub. Today we are going to study one of the most fundamental concepts in electrochemistry, reference electrodes, with, with a special focus on standard hydrogen electrode and the reversible hydrogen electrode. Before discussing standard hydrogen electrode and reversible hydrogen electrode, let us first understand what a reference electrode is and why we need it. In electrochemistry, the potential of a single electrode cannot be measured directly. Only the potential difference between the two electrodes can be measured. Therefore, we need a stable electrode with a known and constant potential as a reference. Such an electrode is called reference electrode. Generally, standard hydrogen electrode is the primary reference electrode and serves as the universal standard for measuring electrode potential. Before we begin, let me ask you a simple question. When we say that the potential of hydrogen electrode is 0 volt, is it always 0 regardless of electrolytic pH? Many students think the answer is yes. However, the actual answer is no. The potential of hydrogen electrode changes with pH according to the Nernst equation. This leads to an important question. If the hydrogen electrode potential changes with pH, why do electrochemists often report HER and OER potential versus RHE? Let's understand why. So for that, we need to know about standard hydrogen electrode. Standard hydrogen electrode is the hydrogen electrode operated under standard conditions. Standard conditions are hydrogen gas pressure is 1 bar, H plus concentration is 1 molar, temperature is 25 degrees Celsius, 298 Kelvin. So, we know that hydrogen electrode reaction is 2H plus 2 electron gives hydrogen. Okay. So, potential of standard hydrogen electrode assigned as 0 is because it is not experimentally showed. Standard hydrogen electrode is exactly 0 volt. Rather, by international convention, standard hydrogen electrode was chosen as a reference electrode and given a value of 0 volt. Why we need to give value of 0 volt to the standard hydrogen electrode? It is because we already discussed the potential of single electrode cannot be measured. We can only measure the potential difference. So scientists need a reference point to compare all the electrode potential. They choose the standard hydrogen electrode as a universal reference and assigned its potential to be 0 volt. Notice that the word assigned, it is not experimentally showed she is exactly 0 volt, rather it is assigned as 0. However, potential of standard hydrogen electrode is 0. It is true only in the case of H plus ion concentration is 1 molar, which corresponds to pH is equal to 0. What happens if pH changes? So, suppose we move from acidic to alkaline condition, the H plus ion concentration decreases. So that according to the Nernst equation, hydrogen electrode potential will also change because pH of the electrode is changing. For example, at pH 14, so we know that this is the Nernst equation. What happens at pH 14? Hydrogen electrode at standard conditions, potential of standard hydrogen electrode is 0. We know that. So here E naught is the potential of hydrogen electrode at a standard condition. So we can put 0 in the place of E naught. So we will get E equal to RT minus RT. The number of electron transfer is 2, so that 2F ln Q, we know that Q is the reaction quotient, activity of product divided by activity of reactant, activity of hydrogen divided by activity of H plus. Okay, so why activity instead of concentration? We know that activity is the effective concentration, so we put the activity instead of concentration. So here we can substitute gas constant, temperature, Faraday constant, and convert ln into log. We will get E equal to minus 0.059 divided by 2 log activity of hydrogen is 1 bar. Activity of hydrogen is 1 under the 1 bar condition, so that we can replace activity of hydrogen into 1. So log 1 by activity of H plus. So when we summarize, we will get E is equal to minus E now, minus 0.059 pH. So at 14 pH, so E is equal to minus 0.059 into 14. So E equal to minus 8 point, sorry, E is equal to minus 0.826 volt versus standard hydrogen potential. So when the pH changes, the hydrogen electrode potential is no longer 0 volt. So how we are saying that? How we are saying that? So what we can do? We need a constant potential even at the different pH. So in this case, we can use reversible hydrogen electrode. So reversible hydrogen electrode is also a hydrogen electrode measured at the electrode potential can be measured at actual pH of the electrolyte. So that RHE scale automatically compensates for pH changes. So that the potential of hydrogen electrode in the RHE scale always 0 volt at any pH, because it the potential of hydrogen electrode measures at the actual pH of the electrolyte. So what is the relationship between standard hydrogen electrode and reference hydrogen electrode? Here you can see that potential of reference hydrogen electrode is equal to potential of standard hydrogen electrode plus 0.059 pH. If the pH is equal to 0, in this case, the potential of reference hydrogen electrode and standard hydrogen electrode is equal or equal. Whereas in the case of pH is equal to 14, the potential of reference hydrogen electrode is equal to potential of standard hydrogen electrode plus 0.826. How it comes? We know 0.059 pH. Instead of pH, we will put 14. So we'll get 0.826. Okay. So these two scales, RHE and SHE, are shifted by 0.826 volt. So now the question is, why do we use RHE scale in water splitting? Because HER and OR studies, in the HER and OR studies, the reaction involves H plus and OH minus ions. Since pH affects the electrode potential, comparing data using standard hydrogen electrode can be confusing. So that, whereas in the case of reversible hydrogen electrode, it removes the pH effect, so that thermodynamically HER always occurs at the 0 volt with respect to RHE, whereas oxygen evolution reaction always occurs at 1.23 volt versus RHE, regardless of whether the electrolyte is acidic, neutral or alkaline. In summary, standard hydrogen electrode is defined as 0 volt when only under standard conditions like 1 molar concentration H plus, 1 molar H plus concentration, 1 atmospheric pressure or 1 bar pressure and 25 degrees Celsius. When the pH changes, hydrogen electrode potential changes accordingly to the Nernst equation and no longer 0 volt versus standard hydrogen electrode. Therefore, reversible hydrogen electrode scale is used to account for the pH effect, making it more suitable for practical electrochemical measurement. I hope this video help you understand the concept of standard hydrogen electrode and reversible hydrogen electrode clearly. If you found this tutorial useful, please like, share and subscribe to Electrochemistry Hub for more electrochemistry lectures and research oriented discussion. Thank you for watching and I will see you in the next video. Thank you.